Okay, hi guys. Just turning this on a little bit earlier. Well, 1 minute, not giving you much time, but if anyone's here, get started on the trig question. I've put it up there. It's on my Instagram as well. So if anyone, I'll start in a couple of minutes, 1 or 2 minutes, but if anyone gets here, then get started trying to find me some solutions. Hi guys, I'm going to start in 1 minute. Get your pen and paper ready and start trying to solve the first question. Try and get me an answer. You get an answer, post it in the chat on the right. If you don't get an answer, then treat yourself to a cake, all right? Just as a consolation. But we don't want cake, not at this time of day. So try and find an answer, post it on the right. Okay. Good morning. Anything to say? Main stuff is welcome, hello. Give me a like on this video, follow me, Paul Tutors Maths on Instagram, subscribe to the YouTube channel. Live maths, we got about 10, 11 of them so far. Yeah, 11, this should be the 12th one. Yeah, go back, watch a different one if you want. There's loads of stuff out there for you to go and check out. Here we've got 2 questions, one AS level, one A level question, a trigonometry question, and a sort of slightly weirder one. And I'm just going to get started, basically. Just going to get started. Okay, so write it out. There it is, that can't hurt. You're looking at it, you're thinking what to do. Probably different ways you could do it. I am going to get going and see where we get with it. My idea is divide both sides by cos theta. You divide both sides by cos theta, you'll end up something like this. And then that's going to cancel to 1. These are both tan theta. And you'll end up with tan squared theta plus 2 tan theta minus 3 equals 0. That's if you bring that 3 across to the left-hand side. Where are we going from there? Well, we could do it with a quadratic substitution. I'm not going to do the full workings, I'm just going to do the brackets. And I'm going to say that is tan theta minus 3, nope, let's check that, plus 3 tan theta minus 1. You with me? That's got a quadratic structure. Now if you haven't seen something like this, you could do a substitution y equals tan theta. Convince yourself that this has got the structure of something like, let's put it in brackets, x squared plus 2x minus 3, where x is tan theta. And so that's why I can factorize it similarly. Then tan theta equals minus 3, tan theta equals 1. That's your two options there. So there you go. So that's the first place to take a pause in this question. They gave us something horrible with various trig identities in it. I divided everything by cos theta. You might have done something different. You might not have got that the first time. You might have tried to divide by sine theta. There's not only one way to do it. It just so happens this is a beautiful way to do it, because it turns a thing into things with only tan. You've got tan squared, tan, and you've got the minus 3. Factorize it, you get these two things. Okay, and here we go. Solving trigonometric stuff. This is the way I do it. This is the way I want you to do it. I'll show two slight variations, but I don't want errors here. Okay, let's try and be slick about it, because errors could easily creep in. We're solving these two, and we're solving them between 0 and 180 degrees. Got to watch for that. That's the interval. And we've got to do it 2 times separately. So I'll do it with this one first, and this is how I would always do it. First I write the angle. And to get the angle, I'm putting the inverse tan of 3 into my calculator. Inverse tan of 3, not negative 3. I'm doing the inverse tan of positive 3. 71.6, shall we say. 71.6. Next, there's this method, the cast method. That's quadrant 1, 2, 3, 4. Now, we've got a negative tan. In which quadrants is tan negative? Well, in the first one, they're all positive. Second one, sine's positive, tan's positive, cos is positive. So the quadrants where tan is negative has got to be 2 and 4. Because the cast thing tells you when they're positive. They're all positive in 1, tan's positive, only tan's positive in 3, so you work out that it's got to be 2 and 4 where tan's negative. So for this one, you're going to be doing quadrants 2 and quadrant 4. I'll just show you another way to get at that, would be just by thinking about the tan graph. What does the tan graph look like? This is also a valid method. Goes up, comes from here, and then it goes like that. That's 360. I've not put all the rest in, but let's roughly draw it like that. That's quadrant 1, 2, 3, and 4. So where is tan negative? It's negative in quadrant 2 and quadrant 4. So however you get at it, you can use method number 1 or method number 2. You might have some other method, but to be honest, these are the two best, so I'd rather you try one of these. You need to work out the right quadrants to use. Then, your actual answers then, theta is going to equal, for the second quadrant, because remember we're doing second quadrant and fourth quadrant, the second quadrant one is going to be 180 minus 71.6, which is your angle. So you're doing 180 minus 71.6. That's going to give you 108.4. Your fourth quadrant will be 360 minus 71.6. Which will give you 288.4. Whoopity boop boo. And that is your two solutions for tan theta equals minus 3. This is your assessment of which quadrant you're going to be in, because it's negative. This is your angle, and there's your two things. Got to do the same again for tan theta is 1. What's the angle? Inverse tan of 1. Allegedly 45. That's what I heard on the grapevine. And actually, your analysis, I'll just do it again. You know, you don't, probably in this case, you don't have to do it twice, but just to get into the habit of it, doing the same thing again. All sine, tan, cos. This time, it's tan positive. Tan's positive in the first quadrant and the third quadrant. This tells you when they're positive. Or you could have laboriously redrawn the graph, because tan graph drawing, you put that down as one of your hobbies and pastimes on your CV. And this would have come out in 1, 2, 3, 4. And this time you're saying, where is tan positive? Again, that's 360. And it's in quadrants 1 and 3. So however you get it, it's quadrants 1 and quadrants 3. You've got two methods you can choose from. There's your angle. The quadrant 1 angle is always literally just the angle, 45. This works for cos and sine, by the way. Exactly the same steps. Cast or graph drawing. Work out the quadrants. And then finish it off. And the way to finish it off, quadrant 1, you just add from 0. Quadrant 3, add from 180. So we have 180 plus 45. So you get 225. So there's all your answers. Theta equals 45, 108.4, 225, That's your answers. Only thing is, now you can check the interval, and they've said between 0 and 180. So this guy's gone, and this guy's gone. If they said 0 to 360, you would have had 4 answers. If they could have given a wider interval, you would have had to start doing things to find more answers higher and lower. Spoiler alert, adding 10360 to all the answers. But we're not getting into that for now. For now, this is just a classic get a feel for the trig methods I would like you to do to solve these, because some people are going to just jump in inverse tan of that and get an angle 45 and leave it there. Do we want that? Does anyone want that? I don't know. I mean, I think there's a couple of guys down the back alleys where I was chatting to yesterday near where I live who said they do like that. But beyond those people, that is not what we want. We've missed an answer if we do that. And we've potentially missed higher answers. And oh, it's drama. It's high drama. Turbo recap and then on to the next question. There's our stuff. Divide by cos theta. Gives you a tan squared equation. Factorize it. That means both of these things must be true. Either tan theta is minus 3 or tan theta is 1. Two separate things to solve then, and each of them you should do the same analysis. Inverse tan of the positive number, so don't put minus 3 in, please. I would really ask that you don't do that. Positive 1 in, gives you your angle. Work out the quadrants where the thing is either negative or positive. So in this case, negative quadrants are 2 and 4. In this case, positive quadrants 1 and 3. Or you can do it with a graph. You know, you've got this casty thingy. If you're not really a big fan of this or never seen that in your life, tan graph will help you if you can try and memorize that. Then for quadrant 2, it's 180 minus. Quadrant 4, it's 360 minus. Quadrant 1, it's 0 plus. And quadrant 3, it's 180 plus. And when I say plus or minus, I'm talking about adding the angle. Okay, so that's a turbo version of it. No more detail right now, but that's definitely a flavour. Pause it and go back if you want to check over that again. Absolutely no problem. I am moving on. In fact, you know what? Let's keep that even there. You can have a look. That's an option. Let's try that out for size. Try that out for size. Try that on for size. Just keep that bit out there. Right. Going on to the next question. So that was your AS level question. Now we are doing the A level question. We're going at a vast rate of knots today. Get in, get out. This is an interesting one. All right, it doesn't tell you what to do. Doesn't say differentiate, doesn't say use trapezium rule, doesn't say factorize. I don't know, we've got nothing. We've got show that is true. So all we're dealing with is this. Now, so you got something that's pretty close to 1 and something to a power. So, okay, you're going to have done some stuff in year 2 to be able to get this probably. Could be good for you if you're an AS level as well, just to give you a flavour of what's to come. And if I've got a little bit of time at the end, I'll maybe talk a little bit about how this links to year one. But I'm just going to kind of go for it, and then maybe can explain a bit better. I'm going to say something like, consider 1 minus x to the, and I'm just going to rewrite 0.9. Okay, stick with me now. Stick with me now. I hope you've put your calculator in the safe and thrown away the key. You didn't really have a key, would you? You'd have a combination code. Don't use a calculator. Now this, so I'm writing it like this. 1 minus something to the power 9 over 10. 9 over 10 is the same as 0.9. So this is binomial expansion from year 2. Okay, when you got something like that, it's actually they call, well, okay, it's with n equals 9 over 10 and x equals negative x, if you like, because that's usually 1 plus x is I think what the formula works for. So if you know binomial expansion, then that's me telling you straight away the stuff. If not, that's fine, let's do it together. The binomial expansion says that, well, let me just quickly write the formula. If it was 1 plus something to the n, that is roughly equal to 1 plus nx plus n minus 1 x squared over 2 factorial plus, and then there's more terms like that given to you in the formula book. Let's put a circle around it. If I've got time at the end, I'll explain to you why that's different to the year 1 binomial expansion. If not, you'll have to work that out for yourself, or ask me maybe. But this is the year 2 binomial expansion formula. So I'm just going to do that, and like I say here, everywhere there's an x, we need to put minus x. Everywhere there's an n, we need to put 9 over 10. And I'm off. So 1 minus x to the 9/10 is roughly equal to 1. Now, so you got that n, so that would be plus 9/10. And then you've got a minus x instead of x, so it's times minus x. Okay, let's keep going. Then you've got plus, so n is 9/10. 9/10 minus 1 would be minus a tenth. Your x goes to minus x, so when you square that, it still goes to x squared. 2 factorial is just 2. Okay, see if we can tidy that up a little bit. And I've done this little squiggly thing to say it's roughly equal to this, because it's not exactly equal to it. Again, might be a chance to explain that in the turbo recap, but for now, let's keep going. I'm just applying the formula. The next phase is simplification. So 1 minus 9 over 10 x. Now, what is this monstrosity? That does not look nice. It's going to be a minus 9 over 100 divided by 2, 9 over 200 x squared plus da 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 da. Okay, done. Now, shout it out if you know, scream it down your television boxes. What x would I have to put in here to make this thing the same as this? Alright, that's 0.9 to the 0.9. I've created this binomial expansion structure, 1 minus x to some power. What does x have to be in order to recreate this? I mean, the power is already fine. It's 9 over 10, which is 0.9. It's just the inside here is 1 minus x. And we've got, okay, so basically it's 0.1. So if I say x equals 0.1, otherwise known as a tenth, then the left-hand side will be, I mean, I could even just put it in quickly, 1 minus a tenth to the 9 over 10, which equals 0.9 to the 0.9. And so now we're saying that's roughly equal to putting the same stuff in on the right-hand side, 1 minus 9/10 times a tenth minus 9 over 200 times 1/10 squared plus the rest of the stuff. What does that equal? 1 minus 9 over 100. Minus, now this thing here, let's just do it for now. I think you'll get 9 over, and on the bottom it's 100, wow. Something like 20,000, because that'll go to 1 over 10 squared is 1 over 100. So yeah, 20,000. So there you go, I'll just write this in again. So there you go, binomial expansion, the year 2 one. Let's keep it as roughly equals because it's not exact. That's the first 3 terms of it. You could keep going and getting more terms, and I'll maybe explain that. Probably will have time to explain it quickly. But the first 3, just using the formula, is this. Now, I'm going to talk to you about this term quickly. Well, it's going to be very quick because it's tiny. 9 divided by 2,000 is pathetic, to be honest. And I don't. It's not often that I like to laugh, insult, terms like this. But it's something like 0.000. How many? If I got the right number of decimal places, 4 or 5. Something piddly. So, to be quite honest, forget it. All right, we don't need it. It doesn't materially change anything. So it's tiny. And actually, you'll notice as the terms go along, they get increasingly smaller. And so really, it's only the first 2 terms that matter. That is 9 over 100, which is 0.09. So if you subtract it, well, let's just turn it into fraction. 0.09, right? And then if you subtract it, you get your answer, 0.91. So we have shown, using binomial expansion, sorry trig people, I'm taking that away. We've shown with binomial expansion, you start with this, you expand it out, you just keep the first 2 terms, because even the third term ends up being tiny. I mean, if you put it on, it would be 0.91045. I don't know, we're not so concerned about this decimal place down here. It's not really much different to 0.91. That's just out of interest. And you get that. But okay, let's just do a turbo recap of the methods. And yeah, let's see then we're done. Maybe, and like I said, I'll just maybe explain how the year 2 and the year 1 are different. There it is. You got to notice that's 0.9, so it's pretty close to 1. Because this being the binomial from year 2, just something small in there for x, you can recreate a number that's not exactly 1, that's just close to 1. So 0.9 is close to 1, and you can recreate that if you make x 0.1 in the binomial expansion from year 2. N, of course, has to be 0.9. I called it 9/10. And then that's all it is there. 1 plus nx plus this stuff plus ends up what? N times n minus 1 times n minus 2 over 3 factorial times x cubed, blah, 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 blah-blah-blah-blah-blah. Plug your stuff in. Can you simplify your fractions correctly? I think probably, 7 out of 9 of you can, if I was being optimistic. But there's maybe those 2 people out there that just need a bit of fraction simplification practification. Get it like that. Then the next kind of thing is to realize, well, that third term, when you plug in x as a 10th, is laughable. So don't really need it, or you could include it and then round to 0.91, but it's the first 2 terms that really carry all the interesting stuff, and you get out 0.91 when you do it. Lovely little question, because it makes you have to think yourself, you have to make the leap from that to the binomial expansion. What am I going to say about binomial expansion? A couple of things. Maybe I could just quickly write the year 1 formula, a bit of it as well. It's something like a plus b to the n equals, how does it work again? What, n choose 0, a to the 0, b to the n, plus n choose 1, a to the 1, b to the n minus 1, plus plus a to the n, b to the 0, well that should be n choose n. Yeah, that's it, right, basically. Didn't do it the most kind of neat there, so. But that's the broad idea. probably come across that, the first year binomial expansion one, where you got something like that, you can expand it. You got to do this choose thing, or Pascal's triangle. I'm a Pascal's triangler from way back, I can tell you that. But also you can do this stuff. It's n, and another way of writing these is n choose 1, like that with a C. You've got a choose button on your calculator. You can find the coefficients, blah, blah, blah. Okay, so for this one, n must be positive whole number. That's the first thing to say. For year 1 binomial, n must be a positive whole number. For year 2 binomial, n can be anything. It can be positive, it can be negative, it can be a fraction. That's a big difference. All right, so think, be aware of that. Be aware of that. That's kind of the reason to choose the year 2 one. If you've got a power of a fraction, you can't use the year 1 one because it needs to be a positive whole number. So that's the first thing to say. Second thing to say is gives definite answer or gives exact answer. The first year 1 gives you an exact answer. If you expand 2 plus x to the 3, you'll get all the terms out. All right, it's not rocket science. They're all there. The year 2 one doesn't give an exact answer. Look at these dots. It's an infinite sequence of numbers, so it keeps going forever. But as you see, even by the third term, they can be very small. What comes out, so it's usually the first few terms that matter, and that's a good thing to get used to, because as you go into university and the future and making approximations, you'll very often use this technique where you're doing a binomial expansion where you got a very small x there, and that leads me into my third point, bit of a spoiler alert, and you can just do an expansion and take the first few terms and use them. So gives exact answer, not exact answer, or let's just say infinite sum. And the last thing just to say, and then let's finish, is that x must be small. In fact, I think there's an official test for it. It is, let's just put it in an extra little bullet point here. Absolute value of x is less than 1. Maybe just try and put an extra little box around that. Absolute value of x has got to be less than 1 for the second year binomial. So, yeah, and also it has to be a 1 plus or minus. So let's not put that as an official point, but you can see the formula. It has to be in the form of 1 plus. Here in the first year 1, you could have any a and any b. In year 2, it's a 1 plus or minus. Well, if it's minus, you'll have to change the x, but and importantly, the x must be smaller than 1, or the absolute value of x. So it could be negative 0.1, as we said in our situation. It can be negative a half, but it couldn't be 7 or minus 10. It doesn't work. So that's an extra little rule. So how about that? How about that as a quick comparison between year 1 and year 2 binomial? Let's just turbo recap that comparison. There's the year 1. Gives you an exact answer. N must be a positive whole number. That's probably the main thing. That's probably the two. And also A and B can be anything. You get 2 different things to work with. The year 2 formula. It doesn't give you an exact answer. It's an infinite. Well, let's see. We're getting that back in action. Yeah, it's an infinite sum. Never ending. You just cut it after a few terms and it's accurate enough usually. X, absolute value, must be less than 1. It's got the structure, so it has to have a 1 at the front there before you can use it. And there you go. But yeah, the main thing is the power. N can be anything, can be fractions, decimals, positive, negative. Thanks very much, guys. Thanks for watching. Give me a like, subscribe to this. Get on my Instagram. I'm posting stuff every day. 3 more live maths to go, then we'll do some more topic questions. Hope you're okay at school. Any problems with your homework, let me know. Always happy to try and help. Raining out there today, not going for my designated daily walk probably. Maybe I just have to walk around the room. So enjoy it out there or in there, and catch you guys tomorrow at 10 AM as per usual. Bye bye.